Good morning. Welcome to another session of EE403 Distributed Generation and Smart Grids. In the last session, we had seen vehicle to grid concepts, and in this session, we will see smart sensors. Before we proceed further, let us see a quote by Abraham Lincoln. The best way to predict the future is to create it. So we are almost at the end of the third part of module 3, and hopefully we will complete smart sensor in this session and home and building automation in the next session. What is a smart sensor? So it is an integrated sensor which has electronics and the transduction element together in one silicon chip. So transduction element means the transducer. So it can be called as a system on chip. The aim of integrating the electronics and the sensor is to make the sensor intelligent, or we can call it a smart sensor. So they have some ability to make decisions. Physically, a smart sensor consists of the transduction element, the signal conditioning electronic, and the controller that support some intelligence in a single package. So we can say that a smart sensor is sensors plus interfacing hardware. Smart sensors are sensors with integrated electronics that can perform one or more of the following functions: data conversion, bidirectional communication, taking decisions, perform logical operations. Here you can see the block diagram of a smart sensor. So this is the transduction part, or the transducer. We have an interfacing module. So the output of the sensor goes to the interfacing module. Inside the interfacing module, there are amplifiers, signal conditioning, and drivers. The output of the interface module goes to the processor part, which consists of normally the A to D converter, some DSP functions, and then finally it goes to the communication section, and the output or the entire information can be transmitted over some communication channel to a remote location or cloud. The processor is also connected with a display and a small memory within it, and then there are some offset adjustment and temperature compensation, etc. too are possible. Here you can see a smart sensor, and you can see here it consists of a 2-axis accelerometer, then a power source, there is a serial port, A to D converter, a microcontroller, and finally a radio modem for communication. This is another smart sensor shown here with 3 different types of normal sensors connected to the interfacing hardware. Another smart sensor is shown here. You can see this is the sensor or the transduction part, and then there is a data acquisition module, and there is a memory, small memory card you can see here, and other circuits, and finally a communication interface to communicate to the outside world. This is IEEE 1451 standard for smart sensor network. You can see here, this is the physical parameters to be measured, and this block is called the transducer interface module or TIM. It consists of TETs, and here you can see various XDCR, which means it can be XDCR can be a sensor or an actuator. So it does not, it can also take some actuating actions, and all these XDCRs are connected to either A to D converters or D to A converters depending upon its input and output. And then there is an address logic, and finally the output of the TIM goes to a NCAP, which is called the Network Capable Application Processor, and this part is called the transducer interface. It can be a wired or wireless, and then the final data or signal is transmitted over any type of network to the cloud. So the components of a smart sensor are transducer electronic data sheet, that is TETs, transducer independent interface TII, transducer interface module TIM, smart transducer interface module STIM, network capable application processor NCAP. This is an example of a smart sensor. A smart accelerometer is shown here. It has a sensing element and some electronics. This is another smart sensor. It is an optical sensor. It is used for measuring the exposure in cameras, optical angle encoders and optical arrays. So similarly, you can also find load cells to measure pressure. This is another smart sensor. It is an infrared detector array. This type of sensors are commonly used by final year students in their final project. Now, the applications of smart sensors. The first application is structural monitoring. So we can install smart sensors at various parts of the structure, and it can detect damages of industrial infrastructure. Another application is geological mapping. So here we use smart sensors to detect the minerals on the geological areas, digital imaging and interpretation of tunnel geology, and remote measurements of tunnel response. Here you can see a smart sensor by ABB. It's a very small device which can be fitted to almost any low voltage motor and can be connected through the IoT. The operational data is transmitted from the sensor to a secure cloud, from where it can be analyzed and transformed into feedback signal, and you can get the information on your smartphone or tablet. These are the functionalities of the ABB smart sensor. It is very simple, user friendly. The downtime can be reduced up to 70%. It extends the motor lifetime by 30%. It can be connected to the IoT, and it improves the efficiency by 10%. These are the references which you should go through, and if you wish to contact me, you can contact me by phone or email. And with that, I am Dr. Unnikrishnan PC signing off. Thank you very much.